Okay, first we check the question. Did you guys try it? It's this one. This question. Brian, did you work it out? Like which way you tried? Oh, okay. Some related. Algebra. Okay. We are checking this one. Yeah. Okay. Okay. Yes, we try to solve this equation. Normally linear. Okay. Okay. For the related algebra, we can have a look at this. What type of formula related to this question? We check that one first. For example, some people tried this way. X minus 1 just equals yz. Y squared minus 2 just xz. Z squared minus 3 just xy. So you have x3 minus x equals xyz. You got y3 minus 2y also xyz. Both sides times by x for the first one, times by y for the second one, times z for the third one. xyz. So they have, x cubed minus x equals y cubed minus 2y equals z cubed minus 2z. Like here, that's like they are working for this one. And of course, there some guy wrote this way and just said, x squared minus 1 equals y squared minus 2 equals z squared minus 3 equals 0, which is not right. You cannot derive from the top one to this one. Okay, we cannot do that. And another one related to here, we have some formula here. Okay, this one, you can change to square form. This one really just same as here, half x minus y squared, y minus z squared, x minus z squared, or z minus x squared. Same, same. And another one, this quadratic, like algebra formula. The other one we have, someone probably know this, 3xyz. This is a formula, x plus y plus z, x squared, y squared, z squared, minus xy, yz, minus xz. Like those formula, this several formula I wrote here look like a similar form with this question on. Here, formula. But when we do this question, we didn't use those stuff. Because the idea for solving quadratic or like a simultaneous equation, you try to find some relations, you can do substitution. You can do substitution. Okay. For example, if you use equation 1 minus equation 2, what you have? We have equals -1. Equation 2 minus equation 3. Just again, -1. Okay, up to here. Okay, nice. Okay, we can factorize this one. We can factorize. Oh yeah, Emma is correct. Emma is correct. So you got x squared minus y squared. Xz minus yz. This one just y squared minus z squared. Xy minus xz. Okay. We can factorize the first one. If you factorize it, we got x minus yx plus y. Z x minus y, -1. Y minus z, y plus z. X, y minus z, -1. Both equations we can factorize further on. We can factorize further. Like x minus y, x plus y plus z equals -1. Y minus z, x plus y plus z, -1. If you compare these two, x minus y equals y minus z. Okay. So we got some linear equation. So 2y just same as x plus z. What's the next step, Emma? Yes. Okay, we substitute this one into here. Because you have y about xz. Okay, we substitute this one first. Have a look. Okay, Yeah, later we can try to substitute into the first equation and have a look on. Okay. We substitute into the second equation. We got quarter squared equals 2. Because y equals x plus z over 2, you substitute into y squared on. Okay. So oh, we got x minus z squared equals 8. Up to here. X minus z could be 2 root 2 or minus 2 root 2. Okay, or minus 2 root 2. Okay. Okay. So up to here, you need to find x plus z. Or you need to find y. Okay. Let's check the equation. Up to here already easier because you have x in terms of z, y in terms of z, everything in terms of z. So you can solve it. For me, I tried. I forgot which way I did, but seems like when I did this, I also tried maybe 1 minus 3 as well. So you got x minus z, x plus y plus z equals negative 2. And we have x minus z now. X plus y plus z equals negative 2. This part is 2 root 2. Y just half x plus z. Here, y just half x plus z. Negative 2. So you have x plus z. Three over 2, x plus z. Negative 2. X plus z just equals negative root 2 over 3. Rearrange, or just root 2 over 3. Is that root 2 over 3? Okay, let's check. 2 cancelled, divided by root 2, so just root 2. Yes. This case, x minus z equals 2 root 2. So you can solve x and z. Okay, that's like how we work it out. Here you can solve x and y and z, because 2y just x plus z and z. Okay. Okay, if you plus them, 2 minus a third root 2, so 3, 5 root 2. So x equals 5 root 2 over 6. Z equals -7 root 2 over 6. This is just negative root 2 over 6, like that. Okay, double check if you can do something about thirds. Just add them up. Okay. Yeah. Of course, you for -1, you have the other one. Just all opposite. Brian, you got the same answer? The other one, just x plus z equals x minus z equals -2 root 2. So x plus z equals positive root 2 over 3. That will be the other possible solution. Okay, fine. Okay. Okay. The other one, because the sum and the minus all just opposite. So the other answer. So the answer should be just this. 5, 6 root 2, negative root 2, 6, -7 root 2, 6. All negative. Tim, any question? Tim, okay. We try to understand the logic product rule. You mean differentiation? Oh, if you got the question, just post to me. I got this question because the school teacher sent to me, ask how to solve it. The teacher just stopped right here, up to here, and not sure how to do it. Okay, but for us, we need to understand the logic, why they designed this type of question. When we try to find the relation this, after we substitute into the second equation, we got a very tidy answer. Very tidy answer. So let's change the question. If the question changed, you cannot have that square thing. What happened? Okay. I'm changing the question now. Okay. But if you can work out, that's pretty good. So we decided to change their question. Equals 4 now, if you can solve it. Okay, if you can solve it. I change this 3, because this 3 finally make here, these two are equal. I change to 4. How you solve it? How you solve it? If we still use this method, have a look what happened. Have a look what happened. still equation 1 minus equation 2. Equation 1 minus equation 2. Oh, same, same, exactly the same. X minus y, x plus y plus z, just -1. But equation 2 minus equation 3, the left-hand side is still the same here. So y minus z, x plus y plus z. But now it's -2. So we have y minus z equals 2x minus y. So we got 3y equals 2x plus z. Compare this, compare this. We got a different one. Up to here. Guys, try to simplify, which means all the questions, all these 3 equations, you can change it into only x and z, because you got y here. Have a try, if you can simplify all 3. If you simplify the first one, that would be, we prefer 3, so 3yz equals 3. 3x squared minus 3y just 2x plus z times z equals 3. That's first one, just convert to this, because 3y, we got 3y. The second one, change to 2x plus z over 3 squared minus xz equals 2. Again, we just make y the subject. The third one, z squared minus x. Okay, we prefer 3y, so y times by 3. 3y just x, 2x plus z equals 12. Now we got the 3 equations. It's kind of quadratics, just power 2. But there's no y, only xz. Okay, check if you can continue. Practice some algebra. Okay, like if we can solve those equations now, you just need to expand, have a look on. If you expand it. Oh, probably negative, probably positive. They didn't really say it's positive. Okay. Hey, the idea, we try to simplify it. You got 3x squared minus 2xz minus z squared equals 3. The second one, we remove it, times by 9. So we got 4x squared plus 4xz plus z squared. Minus 5, 18. Okay, next one should be equivalent to the first two. 3z squared minus 2x squared minus xz equals 12. Let's check if they are equivalent. Yes. We got 4 equations here. And the first two can really give you the last one. Like 5 minus 2 times 4 just gave you 6. So we just need 2 of them. We just need 5 and 4. Because number 6, just another form like about 5 and 4. Okay, up to here, how we do it? Up to here, how we do it? It's just quadratic expanding. Yeah, you can use 4, 5, or you can use 4, 6, or you can use 5 and 6. I need 2 of them. Okay. When we solve equation, we don't like the xz term. For example, we try to cancel it. We try to cancel xz. You can use any 2, any 2 to cancel xz. For example, to cancel xz, 7 times 5. No, equation 6 times 5 minus equation 5. Equation 6 times by 5 equals 60. That's equation 6 times by 5. 5 just here. This is 5. Okay, we try to cancel xz. Minus 14z squared minus 14x squared equals 42. Z squared minus x squared equals 3. Holy. Z squared minus x squared equals 3. We got z squared minus x squared equals 3. Okay, we got z squared minus x squared equals 3. Maybe too nervous. Okay, z squared minus x squared just equals 3. Hey, z squared. Holy, we have something here. Check out z 3 minus 1, what do we have? You got z squared minus x squared minus xy plus yz equals 3. And we got z squared minus x squared equals 3. Which means yz minus x equals 0. Okay, so the idea, we try to factorize or try some algebra way to find the relation between x, y, z. Make something the subject, but a linear one. And we substitute back into the equation to simplify it. For the question on the left, finally we got this. For the question on the right, we got the even easier one. Here give you two possible cases, y equals 0, or x and z are equal. Two possible cases. If y equals 0, guys, solve for x and z. Solve for x and z if y equals 0. Equation just here. If y equals 0. If x equals z, if x equals z, looks like not possible. Why? If x equals z, the first question changed to check. Yeah, that question like we don't really know like what the level look like. All the algebra skill is year 11. Okay, if x equals z, this one just gave you z squared minus y z equals 1. This one just gave you z squared minus yz equals 4. Not possible. So this case, reject. So just y equals 0. Just y equals 0. If y equals 0, we got x squared equals 1. Negative xz equals 2. Z squared equals 4. Hey, y equals 0. Y equals 0. So x could be 1. Z could be negative 2. If x equals negative 1, z will be positive 2. That's the answer. Okay, that's the answer. Of course, if you got time, you can change the number and make your own type of question. Tim, do you know the original question for the product rule? Probably just ask you prove this one times this one. Oh, if you think about the first principle, that would be here. This one equals that. Ask you prove this one, Tim. Oh, who did that? Kevin, did you? Kevin not here. Eh? Kevin not here. Okay. For this one, Tim, I can tell you something tricky. You just plug in a term in the middle, like ux vx plus h minus and then plus ux vx plus h minus and plus the same thing, minus and plus the same thing. After this step, this piece together, this piece together, you can have here and here. Yeah, we don't discuss that much calculus now. Okay. Oh, why is it so sad? Okay. Oh, you can, if you cannot do, for example, you stop here, you can do this way and have a look. What's this? The right side is ux plus h minus ux over h times vx, check here. And the other one is ux vx plus h minus vx over h. This part is the minus and the plus part. These two parts same because h approaching 0. Okay, so for proof, if you cannot go from left to right, you can try right to left. Okay. Okay, let's continue the graph thing. Continue the graph thing. Last week, Brian's proof is valid because I think the question is wrong. I think I post this one. The question is wrong here. The question. Okay, this question. This question, original question, they forgot to write 2 here. Okay. Where's the question? Here. Original question, when I try to copy this part, they forgot 2 here. They forgot 2 here. Now we can show the question. If there's no 2, Brian gave us a counterexample. When you think about, if you feel this annoying, you can just use several. For example, just N1 to N5. Yeah, any way. Just for example. If they know each other, if they don't know each other, there are 2 common like friends. So prove the friends of A1 as many as friends of A2. Okay, read the question. They know each other. Okay, if we use graph idea, A1, A2 know each other, so we just connect it. Okay, so they know each other, but do not have common friend. They don't have common friend, which means A, for example, A know a lot of people. A know a lot of people, like we can say B1, B2, some BK. A2 also know a lot of people. They don't have common friend, like C1, C2, ... C. This is the other one, P. The question just asks you, prove K equals P, like this. So if a friend, we just connect it. A1 and A2 know each other, but do not have common friend. Do not have common friend like this. Okay. How we prove it? We just select one. We assume this piece is a B. B just equals all here. This piece is C. C just all here. C like the friends, A2 knows. Let's check what happened. Any BI here. Any BI in B. That's a math symbol. Just means any people who knows A1. But this BI does not know A2. Does not know A2. Does not A2. So it's not a common friend because BI cannot know A2. So BI is not in C. If be otherwise, BI will be the common friend. Otherwise, BI is the common friend of A1 and A2. They told you there's no common friend A1 and A2. So BI not in C. Okay, so we just check BI here. BI somewhere here. BI. BI know A1. BI doesn't know A2. If BI doesn't know A2, if they doesn't know each other, they are two common friends. Which means BI and A2 has two common friends. Two common friends. One, just A1. They both know A1. Okay? How about the other one? How about the other one? Inside C, like all the friends of A2, the other one must be the friend of A2, which means in C, and the friend of BI. BI and A2 has two common friends. One just A1. The other one must be in C. Okay? The other one must be in C. Someone in C. Okay? Someone in C. So, any friend in A1, you can find a friend of A2 in C. Okay? Which means number of people in B is less than equal to number of people in C. Because any B1, you just pick out. You can find a C in a CK maybe, or maybe CJ. It's the common friend. Okay, of BI and A2. So any friend. The other way around also true. Any C some friend of A2, you can find another B in A1. Okay? So if both ways correct, that means these two just equal. So any BI, you can find one related to A2. Okay, that's why as many as. Okay? Any BI, you can find someone in C. The other B2, you can also find another C. Okay. Okay, yeah, that's the idea. Okay. Let's continue the stuff from last week. Last week we're up to probably the the postman thing. Let's have a look. The postman thing. We're up to I think we're up to the Euler graph just pass through all the edges. Okay, so we're up to, yeah, this one. We're up to this one. Okay, I'll try to yeah, I cannot print out printer. Okay. Just double check the idea. You need to travel all the roads, like here. Every edge, back to the original. Okay, that's this one. The number on the edge, you can say it's about distance. So the question like, first, just some names, just some names. Idea should be okay. For example, what's the meaning of this? This one just means you have two vertices which have odd number of degree. The degree just means how many edges connect to. A and D have odd number of degree. A and D. That's why it's called semi-Euler ring. If you have odd, That means two odd vertices. That means you can travel from one and then like here, you can pass all edges and going back to D like this. Okay? So always you travel, start from the point, the vertex with odd degree, and then travel around, right? Going back to this. So you can pass all the edges. This is type of thing called the semi-Euler. You can say it's a path. So pass through all the edges. Okay. But this question, Chinese postman problem, that's about you need going back to original starting point. You need going back to starting point. So in this question, you need to travel back to A. Okay, just here. Okay, that's the idea. So it's pretty much just one stroke drawing. Okay, next part. For this type of question, again, for this one, how you travel. So you can pass all the edges and back to the starting point. Make the number plus together, give you a minimum value as small as possible. And for this type of question, how we find the minimum distance? Let's have a look. First, this graph, we check number of degrees. Degree, A, there's 3 edges connect to A. B, 3. C, also 3. D, again 3. They're all odd. Okay. That means You don't have like the semi-Euler graph way on. In this case, we need to check. Because both odd. If you travel and back to, for example, you start from A back to A, you need to travel AB maybe twice, AB twice. Okay, because they're odd. Now, the possible way you repeat could be AB. AB together, like A to B repeat, or could be CD. So the first one, AB and CD, this pair. Or, maybe we check how they write here. How they write here. This one. That's what they wrote. That's what they wrote here. It's not the Eulerian or semi-Eulerian, so because they are odd degree. 3 possible pairs of the vertices. AB, CD, just pairing on AB, CD, or AC, BD, or AD, BC. Okay. For A to B, the shortest one just 8. A to B could be here, but we choose the shortest one. So A to B just 8. C to D. C to D. You have C to D just 6. Or you have C to D just 5. That's why here give you 5. Here give you 5. Here give you 8. A to C. You have so many ways A to C, but the shorter one just 7. B to D. Again, 7. A to D. A to D could be 7, could be 6. The shorter one, 6. B to C, 8. B to C, 8. So that's the first step. So if you need to travel, for example, start from one point and going back to that point, you repeat some, you just traverse, repeat some edges. So in this question, we need to choose A, B, and C, D. Because if this one repeat, you got smaller number. Okay, smaller number. So we choose A, B. A to B, you can start from A and then going back to A. C to D. Yeah, so that's the idea. We check the final answer. Final answer. A to B. The efficient one, you need to use A to B and C to D twice. Okay, Okay. Oh, let's check. A to E, 2B, 2A, and then 2B, repeat. B to C, 2E, 2D, 2C. Oh, CD, repeat. D to A. Okay. We check if this is correct. They say A to E, so 4. E to B, 5. B to A, 8. So we travel these edges. We travel these edges. But B repeated, so 8. And to C, 9. And to E, 3. And then to D, 2. To D, 2. D to C, 6. Oh, we use this one. When you repeat from C to D, we use CED. CED here just give you 5. Yeah, and the D to A, 7. So the part we repeat A to B, this one repeat. These two repeat. And the C to E to D repeat, like here. This one repeat. So we got this 13 repeated. What's all together? Altogether, like 20, 44. But C to D repeat, this one repeat, 57. Yes, okay, that's the way. We try if we can do a question. This one. Guys, because school almost holiday you can start doing like AMC 10 and 12 questions for practice. Okay, finally we can write something here. Okay. This one, why? It's a Euler cause all the degree. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. All the vertices got the even number of degrees. So it's called Euler ring. If Euler ring, you don't need to repeat the edge. You can just travel all edges without repetition. So you need to start from L. So L, 2M, 2N, 2O, 2L, 2O, 2N, 2L. Yes. Okay. The distance traveled. Just add them up. 16, 14, so 30, 30, 45, 61, 69 kg, km. Okay. So that's how we find. Okay. Let's travel once. Okay. Okay. Must clear snow, driving all the roads. Starting finishing at the garage A. All distance shown. Is that Euro semi or neither? We check. Yeah. A just 1 degree. C just degree with 3. All other even. So this is semi 1. Semi 1 got 2 vertices with odd number of degree. Okay, which means you need to repeat A to C. You need to repeat A to C back to A. You need to travel all along all the roads and to C and back to A. Repeat. Okay. Check. Oh, we got start from A. D D D D. D D D D. D D D D. D D D D. Okay. So we pass all the edges, but to repeat A to C. Like C to A. That will be 7, 10, 23, 21. 8, 10, 14, 21. Yes. Yeah, 24. 24. So the root just like A to B, to I, to H, to G, to B, to C, to G, to F, to C. Oh, repeat back to A. Okay, this one okay. Move on. Move on. This is like a homework number. Oh, we need to check. If it's more than 2 odd vertices, we will do it as homework. Do it now. But this one is 2. C got the 3 edges. A got the 3 edges. Homework. Number 3 homework. Now, oh yo. Number 4. Okay, number 4. Number 4. You got all 4 vertices, or 5 vertices, but 4 of them odd. We need to try this one. First, we find the pairs. All 3 different ways, like to be paired. AB, CD. AC, BD. AD, BC. We need the shortest path. All the weights could be distance. A to B. A to B, you can travel this way or this way. Both give you 3.5. So you can travel any way. Both give you 3.5. A to B. Okay. But C to D, you can only try C to D to make it shorter. So A to B just 3.5, C to D just 6. CED not short. So 9.5. AC. AC. Six. AEC. 6. BD. 5.5, but BED. BED 5.5. Total 11.5. AD. AD. Oh, A to D. AED is shorter, which is 5. BC, just B to C, which is 5, 10. So we are going to repeat AB or CD. AB and CD. Repeat. Okay. You need to match down all the rows. Okay. So we need to repeat all the rows. AB, CD, AB, no, not that way. Check. A, B, E, Okay, yeah. So we need to repeat DC. So repeat here. Repeat AB. Okay. Starting E. Okay, we can try to start E. But this way we just double check. We pass through all the edges, but we repeat AB and CD. So you just add all weights, add to something km. Is distance? Oh yeah, km. And you need a plus. You repeat AB. You also repeat CD. Okay. What? The question asks you start E. Oh, sorry. We start E. We start 2E. But start 2E, okay. Start E. Oh, we just follow here. Start E. Okay. So that's the way. We find the pairs of odd vertices, and we choose a shorter one to repeat. That's the idea. Okay. Oh, 4, 4, 3, 6, 3, 4. Okay. This one just got the, oh no, I got a degree like a 3. D got a 3. E got a 3. What? 2 got 3. Finish at A, find the shortest possible one. Okay, we try this one. This one. The odd vertices here, here, here. These odd vertices. Oh yeah, these odd vertices. Oh, A also? Oh yeah, and A. Good. Okay. Now, again, we got different pairs. AI, DE, A, D, IE, AE, ID. Okay, like this. A to E, A to E, the shorter one looks like it's 7 on. A to E, the shorter one is 7. A A to B to C to E, which is 7. I to D, it's 8. I to F to D is 8. A to I is 9. Yeah. A to I is 9. A, B, F, I give you a 9. D to E give you 5. D to C to E, 5. A to D, just 4. Just 4. I to E, just 8. To E, just 8. So this one, the shortest one, 12, 14, 15. So you need to repeat AD and IE. Okay. Yeah, for the shortest one, you just add them up and plus 12, the repeat one. You need to start from A and back to A. Wow. Okay. You just try to travel all edges and back to AR, but you need to repeat AD and IE. Repeat AD and IE. We can just do any part, ABD. Of course, we can repeat now, but ABD, ABD, ABD. We need to just travel out. Like you can travel out. So A to B, C, I and E also repeat. So F, G. Here, 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 they all no repeat. We just try to not repeat. Then. I to E repeat, going back here. and you repeat. Okay, so you know which part you are going to repeat. IFE repeat, ABD repeat. Other part just one way. Okay, that's it. Okay. When you check the Hamilton. Okay. Hamilton. The Euler thing, we need to pass through or travel along all edges. But the Hamilton thing, you need to travel or visit all the vertices. Okay, all the vertices. The Euler one, you travel the edge only once. The Hamilton, you just visit the vertex just once. Of course, the starting and ending. Starting and ending vertex is the same thing for cycle. So you visit that point twice. Okay. You just need to visit to all the vertices. You don't have to pass all the edges. Okay. And then this one, just all vertices. The other one, also all vertices. Okay, Hamilton. So Euler, Hamilton, Okay. Let's check that one. You have to find the Hamilton cycle. Here, cycle just you travel all the vertices and back to starting. So you can start from A. So A, all vertices. That's called the Hamilton cycle. If you start E and B, A, down, and B, okay, and B. Like this, okay, here, start from E, stop at B. Just how to sketch, Hamilton. Now, we check here, we almost finished the graph theory, Find the Hamiltonian cycle, start and finish at A. Okay, start from A. What? Not working? Okay. We check, start from A. Finish at A. So we need to travel here. And we need to repeat it just once. Travel the vertex just once. Okay. Then. No, not right. We need to travel the vertex just once. From A. and A D D D D D D here. Okay, it's like A B C E F G D H A. Okay, other part of homework. Number 2. If you can find a cycle. Okay, semi. Okay, check this one. If you can find, we can check for the first one. Is the first one semi-Hamilton or just Hamilton? We need to pass through all the vertex. Here. So it's H, Hamilton. The other one, you can just do here. Semi-Hamilton. This one, semi-Hamilton, just here. And D. Oh. D look like another arm. Okay. Yeah, D nether. This one. Hamilton. Okay, how about the last one? Last one, nether. Nether. Okay, okay, this is nether. You cannot find Hamilton or semi-Hamilton. Okay. Let's check how much we need to learn. Travel salesman, just algorithm. You can have a look first. And the travel sales. And here, yeah, we kind of finished some theory already. Oh yeah. We finished some theory already. You can check the travel salesman by yourself. And in our WeChat group, we have some practice questions. So we finished this part here. This is some practice question here. This one with some summary on. Okay. This is homework. This summary thing is homework. This one is homework. It's in WeChat group. We finished this topic. If we try some question about graph theory, that should be hard questions. Not the basic like this. Okay. Today we got 9 cases. Take care, guys. Check the homework.